Hello. Have you ever wondered how machines can generate text that feels almost human? Or how simple algorithms can create sentences, mimic conversations, or even write stories? It all begins with a fascinating concept called the Markov chain. So, hi and welcome. In today's video, we are diving into the world of Markov chains for text generation. We'll explore how those probabilistic models work, how they use existing text to generate something new, and I'll walk you through my project step by step. So, in this project, I have used Giggle Notebook to build this project. uh, the first thing to do is to import the data set that we will work with. Here in the notebook, we have like add input, like choose data set, and after that, just write the name of your data set that you will use and press this button here and your dataset will be downloaded to your notebook. Or if you will use a dataset that you have in your own PC, local PC, you need just to press upload a new dataset, and after that you can browse your files and choose the dataset that you will use in your project. In my case of this project, I have uploaded my dataset. It's just not dataset, it's just two txt file that I will use to um, train the model. So if you want, you can. I will put those two text in my GitHub. You can use it and in your project, or you can create your own text. Now let's dive into our code. The first line of code is import system. These lines will be provide to install the Python package Markov using the current Python interpreter. You need to wait a little bit until your installation finish. After that, import the Markov that you have just installed. Next, just get access to your text file, which is the your which represent your data set that you have just uploaded or added. Um, Here, since I have uploaded my dataset into Google, I need just to copy. Let me show you. Copy the path from the Google. Here you go here and press this one, and it will copy the path to your text. And you call it here, and after that point read, you will be able to read your text. The line of generator A, Markov text A, creates a Markov chain text generator using the Markov library and the part Markov point text. It analyzes a given text corpus. In our case here is text A, and build a probabilistic model of how words follow each other. In the end, the generator A will be, you can use it to generate random sentence or mimic the style of the input text. In easy word, the trained generator A, can create a new sentence by randomly selecting word based on the probability uh, derived from text A in which we have trained the Markov. Next, we have class sentence by char Markov point text. This class is a custom subclass of Markov point text that modify how the Markov chain model process and generate text. This class contains two functions, word split and word join. The first one split the sentence into character instead of words, and the second one will join those characters into words again. Uh, so, uh, for example, like hello, whole word will be HELLO. This is what the first function do, and the second one from HALLO, it will turn it into hello. This is the role of the second function, word join. And this will generate new text by predicting the next character based on previous ones. This is the use of this class. And by the way, this work well for non-word based text like programming code, DNA sequence, or artistic things. This line can model sentence by char, um, create a Markov model using the sentence by char class, which generate text at the character level. This string input serve as the text corpus for the Markov chain, and the state size equal to define the size of the state used in the Markov chain. In this case, too, mean the model consider two character sequences to predict the next character. What it mean? Like in this word, we will have CO. After that, we have ON. After that, we have ND. Like we go two character by two character. This code set parameters for generating text with a Markov chain model. So let's dive deeper in those parameters. The first one is level word. This sets the level of the text generation model to word instead of character. So we have mentioned in the previous function that we will use character instead of word. Here with the level, we have choose to work with word instead of character, which means the text will be split into word rather than characters, and the Markov chain will generate text based on word sequence, not character sequences. The second parameter is order equals 7. The purpose of this parameter is to define the n-gram order for the Markov chain model. What does this mean? So the model will not use only the previous word to predict the next word. No, it will use 7 words, the previous 7 words to predict the next word. This will allow the model to capture more context and structure when generating the new text. Output n equal 14 will control the number of line or sentence that the model will be generated. The weights 0.5, 0.5. It determines the weights between two different text models, text A and text B, that we have called from our data set. A weight of 0.5, 0.5 means that both models contribute equally to the generated output. The length limit it's limited the length of the generated text in term of character, which means the text output will be truncated to 218 characters or fewer, ensuring the text fits within a specific limit. This is useful if you are targeting a specific text length, such as for a tweet or short message. Now the last part is to dynamically choose between generated text at the level of word or character using the Markov chains. The first line model CLS Markovi point text if level equal word as sentence by char. This line dynamically choose the appropriate model class based on the level variable. So, which means if level is set to word, it use Markovi point text, which split the text into word and build a word level Markovi model. And if the level is not word, it used the sentence by character class, which work at the character level, which means split the sentence into character, not into word. The second line is Gen A, model CLS text A, state size order. This will create a Markov chain model for text A, uh, our data set, either at the word or character level, and the state size, as we have mentioned before, it will be 7. Same thing for the chain B. And the line of chain combo, Markovi combine chain A, chain B, weights, combine text A and text B models using the specified weights, which is 0.5, 0.5 in our case. So the output will be a mix of both models with equal weights given to each. For E in range output N, this loop runs for 14 because output N, as we have mentioned before, it's equal to 14, mean it will be generate 14 sentence or piece of text. Next, out equal gen combo point make short sentence length limit text output equal false. Generate a sentence from the combo model gen combo. The length limit will be 218 characters. The text output false. This flag prevents testing for overall short or invalid sentence. Make short sentence. Ensure that the generated sentence fit within the length limit. And finally, out equal out replace slash n. Replace the new line character with space to ensure the generated sentence is in a single line, particularly useful if the output contains unwanted line break. Print out will print the generated sentence, and this is our sentence here. They are in the same profession, you know. This text, as you can see, I didn't count the lines if it is 14 or not. But this text is generated using the Markov chain and combining the two texts we have given to it as data set. Thank you for your interesting. That's a quick dive into generating text with Markov chains. I hope you found it interesting. Bye bye.